putting down, hey Tim, we are putting down our pencils. Everyone's putting down their pencils, and gentlemen, now is the time to go throw them up. So there you go. Thank you. So you're going to put down your pencils and watch what I'm telling you. So I swear I've given this introduction now. This is my third time. Caesar's watching me. No one cares about the introduction. I'm not going to lie. I spend time on it, but you all are like, just give us the formula. And I get that. But let me tell you what we're doing. So if I said to you, hey, you have a test, you got your little unit circle out, and I say, find the sine of 30. And you're like, yay, so easy. And you've got your unit circle. It's so pretty. You pick this out. That was frightening that you just scared me right there. You pick this out, you draw that guy, and you get 1/2, and you are right, and you're feeling so good. And then strangely, your unit circle spontaneously combusts. It burns up, and all of a sudden, it's gone. And you're like, oh crap, now I'm screwed, right? And then the next problem says the sine of 60. And you, being the clever person that you are, think to yourself, well, wait, that's just double that, right? So if the sine of 30 is 1/2, then two of them would just be timesing this guy by 2. So it would just be 1. And you'd feel so clever, and you'd be like, yay, I didn't need that stupid unit circle. And then you get out, and then you look it up, and you realize, holy crap, the answer is actually √3/2, which is nowhere close to that. And that's because here's where we've gone wrong. And I've said this before, and we'll say it again. What we're actually trying to do there is distribute. We're trying to distribute that 2, and we can't. Trigonometry is not commutative over distribution, meaning we can't distribute. So guess what? When we want to take an angle of anything, sine of anything, and then we want to double it, times it by 2, guess what we have? We have a formula. So here we go. Purple paper out, little righty thing out. I'm going to give it to you. Is tonight's stuff easy? So easy. You will actually like tonight. You're going to write this. This is the title for this. We do double angles today and half angles tomorrow. And then we're done with the formulas. We're almost there. So I'm going to give you a minute before I give you the formulas to get it all set up nice on your purple paper. Tim, write them down. Okay, are you ready? Here comes the first one. Write this down. Here's what we mean by double angles. Let me tell you what we're watching for. We're looking tonight for this. 2 times an angle. We know how to get a regular angle. That's easy. But how do we double it? You don't get to distribute. You don't get to just times it by 2. That would make sense, but we don't get to do that. Same thing, we can't do that for logs. When we do the logs next chapter, you don't get to just times it by 2. And when we do it, you'll be like, oh, that's right, we can't. That is cosine, or that is sine. And for those of you who are speedy, quick at writing, here's your cosine one. Again, you want to watch for that. It's the 2 theta tonight that's going to tell you, oh, I need to go to my formula. Because I think that's going to be the hard part on the test, is knowing how to use the damn sheet, right? To know which one do I pick it off of, right? Oh, not only is cosine weird, I'm going to tell you something about it, but you'll like the Mrs. Tarantino way. Lots of teachers teach not only that, but 2 other crazy additional ones. I'm not going to do it, but I'm going to show you what they do. They get rid of that sine squared, so they go like this. Cosine squared theta minus 1 plus sine squared theta. Because they pop in that, they pop out, they pop out that, and they pop in that. But here's what. and they do a whole nother one. We're not doing that. And I'm going to tell you why. Because a lot of teachers just teach this. I'm going to give you an angle tonight, and they're going to say, oh, well, if they give you that angle, you want to just use that angle. But we don't. We draw the triangle. And when we draw the triangle, we get all the pieces that we need. So we don't need a bunch of formulas. We need one. So when you get to pre-calc or college algebra next year, or even calculus, drawing the triangle is the smarter way, right? But does the textbook say, hey, draw a triangle every time? It doesn't. So I was watching a video, and the teacher was teaching it this crazy way, but when she was doing the problems herself, she kept drawing the triangle. So that, I know, because it's the smarter way. It's the smarter way. Yeah. No, we are going to, the last one will be, so this is double angles. The last one that we do tomorrow will be sine of half. So we'll have one last section, and that'll be it. Okay, so, and usually we do them in 2 steps, but these are easy enough, doing them both together. Okay, are you ready? We're going to do 2 examples. It's that easy, 2 examples. One that's going to be super easy, one that's going to be actually easy, but a little bit harder. You can do it on paper. You can do it on your whiteboard desk. You can do it on your arm. These are that easy that you don't need to look back. Once you get the hang of it, you'll be like, oh my God, so easy, so easy. So write this somewhere. So whiteboard desk, wherever, here we go. Looks like what? It does. It looks like sine of 20. It does look like sine of 20, but it's 2 theta. So here's what. If you find your triangle parts, these problems are so easy. And it's when some instructors teach this by trying just to use a fraction the whole way through that they're hard. But if you take literally 30 seconds and find all your parts to your triangle, this problem becomes a walk in the park. So the first thing I want you to do on all of these problems is what we did last night. Take a minute and get all your triangle parts. So this is literally Pythagorean theorem, right? A squared, B squared, C squared. I want to know what C is. Take a moment. And by the way, 169 is 13. Just saying. You did say that. I'll get you one, Jace. We're going to use it. Any other table groups want a calculator? You got that? I need a calculator. Look. Anyone else want a calculator? Because y'all have your phones because you're bad people. There you go. Because you're not. Okay, so here we go. Almost everyone got 13. Yay! Watch how easy this is. So step 1, go to your formula sheet. Yay! Step 2, write the formula down. 2 sine theta cosine theta. Yay! We love this one. This one's easy. I'm going to double check it that I made sure I write it right. I did. Yay for me. Step 3, pop out sine theta and write the number for sine theta. So in other words, the 2 is going to stay, but now instead of having sine theta, oh, look who makes an appearance. Little baby Sokotoa. He's back. I'm going to put him right here. Yay. I miss you, baby Sokotoa. I'm doing sine. Opposite over hypotenuse. 5/13. Yay. Now we're going to do cosine. Cosine is so weird. It's Miss Merritt has a dog. I don't remember her last name. 12/13. There was one time they had a like on the Bronco broadcast. They had a thing about the wellness center, and it was a kid, and he like went to pet the dog. Swear to God, if you watch that video, the dog almost bites the kid. Like the dog goes, and I thought, oh my God, like it's my favorite video of all time. Like, hey, wellness. I thought that's just so classic. There we go. So here we go. Oh my God, we're kind of lame when it comes to multiplying fractions. But you know what you would do when you multiply fractions? You multiply across all the numerators times 2 times 5 times 12, and all the denominators times 1 times 13 times 13. It is 120 over 169. Is it a dumb answer? Sure. Is that it? That is it. No, 169 is 13 times 13. Nothing goes into 13. But I had to, I mean, I think about it. Like I didn't know that off the top of my head. Okay, that's the first one. Let's try the second one. It is easy. I'm gonna move my thing down a little bit. Let's remind ourselves that dude is 13. So here, let's do cosine. Cosine's a little bit tricky because it's got some squares in there, but we're not babies. We got this. So let's write our formula down. Cosine squared theta minus sine squared theta. Now, let me remind you what we're actually doing. We're taking the cosine theta, we're taking the number, and then we square it. Even though it's written differently, we're taking the whole thing and squaring it. It's just written in a weird way. So cosine is 12 over 13, and we're going to square it. Minus 5 over 13, and we're going to square it. Here's what's nice. Common denominator all night long. So it's not like, oh my God, I've got like weird fractions that are not going to subtract. No, they're going to turn out really nice. Dumb, true, but nice. Squaring is square the top, square the bottom. 144 over 169. Take away 25 over 169. If you are, some of you have your phones, if you got a calculator, if you come up with 119 over 169, you're a genius and you think, does something go into those? No, they're both stupid numbers. Nothing goes in there. Told ya, light work tonight. Light work tonight. So the only thing we're going to add in is let's move our triangle in different quadrants. And that's it. It's the same stuff, right? It's the same stuff. It really isn't bad. So everyone ready for me to go to a new screen? Yeah, okay. We're skipping that one. It's too boring. Here we go. So this is the thing where other teachers teach it trying to do the fraction the whole way through. And my theory is this. Don't use the fraction the whole way through. Build a triangle. It's so easy. It takes 30 seconds and you will get these right every single time. So the first thing we're going to do is we're going to come over here and build ourselves a little triangle. On your desk, you're going to build a triangle, but here's what I need you to do with your neighbors. Put your triangle in the right quadrant, right? This is where our triangle's living. He's living over here. So Tim, make sure when you draw your triangle right now on your whiteboard desk, like we're doing, are you drawing a turkey, Jace? Put your triangle in the right quadrant, right? So he's down here. So he's going to look like this. Boom. 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 Okay. So here we go. Nice and easy. It gives us the cosine. Cosine is going to be adjacent over hypotenuse. Nice and easy. Nothing scary there. 1 there, 4 there. We're going to need a number right there because once we have that, these are so easy. The number on this one's going to be a little bit uglier because we're pre-calc, right? We can do that. So do it. Check with your neighbor. I'm going to give you a hint. It will be negative because we're going downward, right? And it will be a root, but it won't be it will just be a dumb root. It won't be a, yeah. Yeah, just make sure it's negative. Negative. If you got negative root 15, like Kristen and Jay Scott, you are on fire. Did I lose anyone there? I did 16, take away 1. We cool? We're gonna leave it just that. It doesn't break into anything. So let's start with tan, just for the hell of it. I put tan up there just because, and that's just up. Remember, we're gonna get little Sokotoa out. Here he is. We're just gonna do old opposite over adjacent. And if you're like, really, Miss T, is it that easy? It's like, yeah, it is. If you draw the damn triangle. If you try to do this from that, yeah, it's a pain in the ass. If you try to use trig identities, ugh. That's how other people teach it. We're just gonna do it. Okay. I put it C because I like it better. I want to do this in this order. So let's start with sine 2 theta. Nice, easy. Do your formula first, right? So write your little formula down. I love this one because it's easy. It's just 2 sine theta cosine theta. And if you want to make sure you're looking it up, that's, oh, I'm just writing weird things. Cosine theta. Now I go to my triangle. And again, there are other teachers that are teaching it by using that fraction, but we're just going to go to the triangle. So we're going to say sine. So first we're going to start with 2 over 1, 2 over 1. And then the sine is going to be root 15 over 4. And the cosine is going to be 1 over 4. Now a quick reminder, when we multiply, people will multiply with anyone that they're around. So if you're in jail, you multiply with other jail people. Don't judge them. Jail's difficult. And if you're out of jail, you don't get to multiply with people in jail. That's weird. Don't do that. So outside people with outside people, inside people with inside people. If it helps, put a little 1 right here, right? So you know that. So here's what I got on the top. 2 times negative 1 times 1. So it will be negative 2 on the top, and the root 15 has no other jail friends to multiply with. He's in like solitary confinement. And on the bottom, I get 1 times 4, which is 16. Now, some of you would be like, yay, I'm done, and I got 100% on the quiz, and then you're going to get it back and be like, she took a point off. This baby can reduce. Inside guys reduce with inside guys. Outside guys can reduce with outside guys. So do we see a little bit of reducing we can do? Negative 15 over 8. Beautiful. Beautiful. That's it. Nice. 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 We got one last one and I'm shutting up. Are you guys ready? Here we go. I am going to get rid of all of this. I am going to get rid of all of this. I want to keep my triangle there, and I want to keep Sokotoa because he's beautiful. Okay, last one, best one, and I'm going to be quiet. I'm going to let you guys try this one kind of on your own. There you go, last one. Get out of here, get out of here. Do it. I'm going to walk around. Thank you so much. Yes, I will. Thanks. There we go. Everyone's doing this. I'm walking around. Do this one on your own. Don't forget, when you square something in a square root, it gets freed, right? So squaring square roots we like. So now you can see why they taught those other ways, because if you had to use cosine for everything, oh, but why? Just draw the damn triangle, right? I'm taped. Are you okay? I just don't want you to be uncomfortable. Root the negative 15 squared. It becomes positive 15. The negative and the negative go away, and the root and the root go away. Oh, okay. It becomes, no. You got to use a little formula. What's the formula? Cosine squared minus sine squared. Yeah, cosine squared minus sine squared. So just negative 15. So it becomes out just normal positive 15? Yeah, normal 15 is the square root, get rid of the root and the negative. So is the answer just negative 13 over 8? I think it is, oh, don't forget to square your bottom. There you go. 1 minus, right? Beautiful. Oh, that was Yep, yep, yep. I think it's negative 7/8. You'll see why. Hey, here's what I got. Did you get this? What? Did you get that? You want me to do it? Okay, so here we go. So this one is cosine squared minus sine squared. Yay. Okay, so let's take the cosine squared. That was easy. I just take that 1/4. Nice and easy. 1/4, but I'm going to square it. Sine squared is a little nastier, but that's okay. It's negative root 15 over 4, but I'm going to square it, right? Everything's looking good. Have I lost anybody? Okay, so watch what I'm going to do. I'm going to move some stuff out of the way. Get out of here, dude. Okay, so I'm going to go up here. So, because it is a little messy. Have I lost anyone at this point? Okay, so I'm going to square that. 1 times 1 is 1. 4 times 4 is 16. You're not babies. You guys got that. So 1/16. Yay. The minus is not getting squared right here. So he stays. Now, we're doing this guy. Let's do the 4 on the bottom first because we're babies and we don't want to cry. There we go. He's good. Now, let's talk about what happens when we square a negative. A negative and a negative become a positive. So he goes away, right? Just plus. And the root cancel each other out. That's what squaring and square root do. They're opposites of each other. So just 15. So look, the denominator is easy. 1 take away 15 is pretty easy. Negative 14 over 16. And you're like, but Miss T, you didn't say that as the answer. Because I reduced it. That's it. Yes. Because we're just subtracting. And you know it's nice? Common denominator. Boom. We're good to go. Yeah, and it'll work out that way tonight. I am stopping. Goodbye, my friends who are in Tapelandia.